In the class, we are going to discuss the important problem in change of order of integration. In the last class, I have explained what is called the change of order of integration. Continuation of this last class, in the class we are going to discuss one more problem in change of order of integration. Use the thread to write the question. Write the question: change of order of integration in change of order of integration in double integral over outer integral 0 to 1 inner integral x to 1 x dx dy divided by x square plus y square and then evaluate. This is the question. Let's go to write the answer for this. Write the solution for this problem. So what is the first step? First step is you have to check that what are the limits for the integration. What is the inner integration with respect to x? As I told that in case if it is inner integration is with respect to x, the limit should be either constant or function of y. Okay, if it is in terms of x, that should be in terms of y. Therefore, that order is not correct. We have to change the order. The given integration should be right in the order I equal to double integral over 0 to 1 x to 1 x dy dx. That is the correct order by x square plus y square. Therefore, the region of integration, what is the region of integration here? The region of integration can you tell me that what is the region of integration here? Inner integration is y, so this is y equal to x, y equal to 1. Therefore, y lies between x less than or equal to y less than or equal to 1. Similarly, the outer integration is x. Therefore, the limits from 0 to 1. That means 0 less than or equal to x less than or equal to 1. Therefore, what is the region of integration? The region of integration are bounded by the straight lines, bounded by the straight line. What are the straight lines are there? Y equal to x, comma y equal to 1, and then x equal to 0 and x equal to 1. Okay. So you have to draw the rough diagram for this. Rough diagram. How to draw the rough diagram for this? First you have to identify the shapes. What are the shapes are there? It is 45-degree straight line. Y equal to 1 is the straight line. X equal to 0 is the y axis. We know that. And then x equal to 1 is the straight line, constant line. Okay. So how to draw the diagram for this? Okay, let us draw the diagram. x axis, y axis. See that what is the first line? 45 degree straight line y equal to x. Draw that 45 degree straight line y equal to x here. Okay, so here that angle is 45 degree, and then x equal to 0, x equal to 1, y equal to x, y equal to 1. So we can take that the equal intercept here, x equal to 1. For example, approximately I am drawing here. So this is x equal to 1, it is y equal to 1. Therefore this point is 1 comma 1. Let us say it is O 0 comma 0, and then if it is the point A is 1 comma 0, and then we can write it as B and it as C. C is 0 comma 1. Okay. Next we have to identify the region of the integration. So how to identify the region of the integration? What is the inner integration axis? Y. So you draw the parallel line to y axis. Draw the parallel line to y axis. If you draw the parallel line to y axis, then we can see that it is a parallel line to y axis, and then end of this, is it not? So you have to try end of this. So this is up to this. It is parallel line to y axis, is it not? So here we have to identify what is the region. So what is the starting point? Y equal to x and y equal to 1, is it not? Where is y equal to x? Y equal to x, this straight line, y equal to 1, this is y equal to 1, is it not? So start from y equal to x, end with that y equal to 1. Then what is the region of integration? What is the region of integration? So let us draw this y equal to 1 solid line here. Okay, so starting from y equal to x, ending with y equal to 1 means this is the region of integration. So based on this double integral, first you have to identify what is the shape, and then you have to draw the rough diagram. From the rough diagram, what is the integration starting point and ending point? First you have to draw the parallel line to inner integration axis y, and then here starting point is y equal to x, starting point is y equal to x, and the ending point is y equal to 1. Okay, and then see here, starting point is y equal to x here, and then ending point is y equal to 1. So anywhere in the region you draw the straight line that should be satisfy that condition. Okay, so next you have to change the order of integration. It is our question, is it not? Change the order of integration. So after changing the order of integration, right now, after changing the order of integration, after changing the order of integration, how to write that the integration I equal to double integral over the region R x dy x, already it has written dy dx, so you have to write dx dy divided by x square plus y square. Okay, now you have to identify the region, identify the limits now. How to identify the limits? What is the inner integration axis? X. So you draw the parallel line to x axis. Now you draw the parallel line to x axis, what you get? change the color. Draw the parallel line to x-axis in the region. This is the parallel line to the x in the region. So therefore it start from, we can see that where it start from x equal to 0. It is y equal to 0, x axis is known as y equal to 0, y axis is known as x equal to 0. Start from x equal to 0 and end with the straight line y equal to x. So that means x equal to y. Therefore, after changing the order of integration, I can be written as I equal to double integral over x dx dy divided by x square plus y square. Actually, when you are doing the problem, it is not the matter how slow you are doing or how fast you are doing, but only that thing is you have to do correct way. That is, you should not skip even a single step, then only you will get that right answer. So here, what is the starting point? You can note down here what is the starting point. Starting point is x equal to 0. That is, we are going to write that the limits of x equal to 0 and ending with the straight line x equal to y. See, in the last class I explained how to write the outer integration limits. For the outer integration limits, no need to see in that the region. That is, you have to see in the axis. What is the y axis? You are going to write that y value, is it not? So see, in the axis, y axis, it is starting value and it is a ending value, is it not? This is the starting value and ending value. What is the starting value here? I can write that the starting value O is 0, 0. End with, it is start is O, end is the point C. The point C 0, 1. This is a shortcut to write that. Listen, that is, no need to consider about the x value here. Generally, how can we write that the coordinate x comma y na? So here take only that y value. This is the starting point and ending point of that y value. Okay, so what is the y value here? Y equal to 0 to y equal to 1. It is very simple procedure to write the limits of the inner integration and outer integration. Only thing is, you have to identify shape and rough diagram properly. Draw the rough diagram properly. The other things are very simple integration. So here next one is you have to integrate it. How to integrate that? That is x dx dy divided by x square plus y square. First you have to integrate with respect to x, keeping y as a constant. So if you take that x square plus y square is t, then 2x dx equal to dt, because in the numerator x dx is there. In case x is not there, then it can be written as dx divided by x square plus y square. It is in the format of a square plus x square format. The answer is 1 by a tan inverse of x by a, x by y, is it not? But here numerator x is there, so we can write as x dx equal to dt by 2. Actually, what is that integral over dt by t formula? That is equal to log t plus c. That is the formula. So here, in case if you are taking like that, then the integration becomes I equal to 1 by 2, and the outer integral 0 to 1 you have to write 1 by 2 log x square plus y square. Using the substitution method, we are getting here. What is the limit here? 0 to y. Then if you are substituting the upper limit and lower limit, we will get that 1 by 2 integral over 0 to 1 log 2y square by y square. The outer integration is 1 with respect to y. So here y square get cancelled. Log 2 is there. Log 2 is constant, we can take it that 1 by 2 log 2 outside. Integration over 0 to 1 dy is there, na? Then integration of dy is y from 0 to 1, you will get 1. So what is the answer for this? 1 by 2 log 2 is the answer. So it's a very simple problem, the change of order of integration. We will see that one more problem in the class. Take that pen, write that example number 2 in the class. Example number 2, change the order of integration in. Change the order of integration in integral over 0 to b, integral over 0 to a by b, 0 to a by b, b minus y, b minus y, xy, dx dy. And then evaluate it. And then evaluate it. Write the solution for this. What is the first step? First step is you have to identify the shapes in the limits. Okay, so the region of integration, write the region of integration. The region of integration R is bounded by, can you tell me? Bounded by the lines. All are lines x equal to 0, because inner integration is x na, so it is x equal to 0 and then x equal to a by b, y equal to 0 and y equal to b. These are the limits. So therefore bounded by the lines x equal to 0 and then x equal to a by b into b minus y comma y equal to 0, y equal to b. You have to draw the rough diagram for this region. How to draw the rough diagram for the region. So here draw the y-axis and the x-axis. Here you can see that x equal to 0. X equal to 0 is y-axis. And then second one, x equal to a by b, b minus y is given. X equal to a by b, b minus y is given. So if we expand it, a, b, b get cancelled, that is equal to a minus y by b is there. Otherwise if you take that a here, x by a, otherwise we can write x by a, b, b get cancelled, that is 1 minus y by b. So that implies what you get, x by a plus y by b equal to 1, which is the straight line. Intercept to form with the intercept a and b. So here in case if it is y intercept is b here, x intercept is a here, then you have to draw the straight line from this. This is the straight line, which is, otherwise we can draw that one line we can take, and we can put here. Okay, maybe move the line. draw the shape here. Draw a straight line we can take here, then draw from here to here. Okay, this straight line properly right here. So next one we have to write the points. So what are the points here? It is a comma 0 and then 0 comma b. This is the 0 comma b, and this point is O, 0 comma 0, and then what is the straight line? X by a plus y by b equal to 1, is it not? So this is the rough diagram for this. Then what is the region for this? What is the region for this? Starting from 0 to, you can see the region here. What is the starting point? Starting point is x equal to 0 to the straight line. Inner integration is with respect to x, na? So draw the parallel line to x axis. If you draw the parallel line to x axis here, starting from x equal to 0, end with the straight line x by a plus y by b equal to 1. Okay, that is the region. So therefore here we can draw the region of the integration. You draw that region of the integration here. This is the region R. Is it not? What is the next step? Next step is you have to change the order of integration. So after changing the order of integration, after change the order of integration, change the order of integration, the integration I becomes double integral over the region R xy dy dx, dy dx. Now the inner integration is with respect to y. Therefore, how can we write the integration? That is equal to double integral over xy dy dx. Already I have written in terms of x, is it not? The same thing we have to write in terms of y. So how can we write the straight line? If you draw the parallel line to y axis, you draw the parallel line to y axis, because it is the inner integration now. Parallel line to y axis, it is start from y equal to 0, you start from y equal to 0 to y equal to, wherever that a is there you have to write b, b by a, it can be written as a minus x, is it not? To write that outer integration, as I told, that you take what is the values of x here, 0 comma 0 and a comma 0 are that x value. So here 0 to a is the limit for x, is it not? So if you are solving this, you will get, that is, you have to evaluate it. The evaluation is very simple, but the drawing that rough diagram and writing the region is very, very important thing. Once you identify the region properly, the other things are very simple. 0 to a and then x into y square by 2, 0 to b minus a into a minus x dy dx. So b square by 2 a square, taking outside, b square by 2 a square, integral over 0 to a, and then x into a minus x1 square dx, x into a minus x1 square dx. So b square by 2a square, how to solve that? B square by 2a square, and then if you expand it, you will get that a square, and then integrate it, x square by 2 minus 2a x cube by 3 plus x power 4 by 4, and the limit is from 0 to a. So if you are taking that a square common, what you get? A square b square by 2 because here a square and then a square will come, therefore a power 4. If you are taking a power 4 outside, already a square is there, cancel that. A square b square by 4, 1 by 2 minus 2 by 3 plus 1 by 4. So which gives that answer a square b square by 24. Simplifying this with the answer. So in the class we are discussing two problems. In the from the two problems you have observed one thing. In the first problem, in case the problem is given in the different order, means you have to identify the order properly, then you have to write that. Okay, don't think that the question is wrong, it is correct question only, but you have to identify that order properly, that's all, based on the limits. And then drawing the rough diagram and identifying the region is important. Afterwards the evaluation part is very important. When you are doing the evaluation, then you should remember all the integration formula properly. Okay, thank you, see you in the next class.